Hello everyone, hope you're having an amazing day. I'm Izhou Qian, you can call me Tai or Dr. Q, and I'm excited to talk with you about Apply AI in Sport Management. This is a series of videos aimed at introducing Apply AI into the sport management community. I understand we have folks with varying coding experience and AI familiarity, so I'll keep this video series conversational and accessible, while still giving you plenty of substance. We'll cover a bit of AI and machine learning background, some tools you can use, and a bunch of practical demos and examples. We will also discuss limitations because AI isn't all magic, and we all know that. And then we'll look ahead at what's coming and how you can get involved. So our today's video will primarily focus on basic natural language processing, or NLP. But before we dive into the details and demos, I will briefly introduce how you can access resources made available to you for free, like GitHub, Hugging Face, and Google Colab. All right, so first we have GitHub, which is a platform that allows you to host, share, and collaborate on code projects. It's where developers or just anyone store their repositories, track changes, and work together seamlessly. For example, my GitHub repository specifically designed for this video series, AI Conversation, contains resources and code examples related to AI applications. What you need to do is basically Google search Tyrell Q, AI Conversation, and I believe the first result pops up will direct you to this web page. So next we have Hugging Face. It's a hub for machine learning models. It offers a vast collection of pre-trained models that you can utilize for a variety of tasks, like sentiment analysis right here, text classification, you have text generation, computer vision as well, like image classification, object detection, and also audio, right? You have text-to-speech, so on and so forth. It's so much more, and it's very powerful. So these models are accessible through the Transformers library, making it very straightforward to integrate advanced AI capabilities into your projects, which we will be covering momentarily. And last but not least, we have Google Colab. It's a cloud-based Python notebook environment that allows you to write and execute code directly in your web browser. It's perfect for experimenting with AI models without the need for any local setup. So very user-friendly. So after covering the essentials of GitHub, Hugging Face, and Google Colab, we can now move into natural language processing, or NLP. So NLP is all about enabling computers to understand and process human languages. So our today's focus is sentiment analysis, determining the emotional tone behind text. Businesses use this technique extensively to gauge customer opinions about products or services, and sentiment analysis generally characterizes text as positive, negative, or neutral, giving instant insights into public perception. But when it comes to sentiment analysis, it's actually a little bit more nuanced. We have multiple ways to perform sentiment analysis. So first, we have lexicon-based approaches. We will be demonstrating using Vader. And we have traditional machine learning models like Bayes, and we have advanced deep learning methods, which we'll be demonstrating through BERT. The thing is, we can actually conduct sentiment analysis very straightforward using Hugging Face powerful Transformers library on Google Colab. And how can we do that? Well, it's actually super straightforward. All you need to do is to utilize the link provided, which will direct you directly to this web page, or you can type in TyraQ GitHub on Google, and the first result you will have is my GitHub homepage, and you can do the same by clicking AI conversation. And here we go. The homepage for our resources for this video series. So next, what you need to do is click Basic NLP. And right here, you can see this is a description of what's going on in this folder. And next, you click Basic NLP .ipmb, and that will direct you to the code book. And what you need to do is to open in Colab, click that button, and that will direct you to the Google Colab. So assuming you have already signed in Google Colab with your Google account, and what you need to do next is save a copy in your own drive. And here you go. You save a copy and you can actually run all the demonstrations on the web browser without any issue. So what you need to do is simply follow with me and experiment, and we'll go from there. Cool. Now with our Google Colab environment set up, we can now run the demos on the sentiment analysis. But before we actually perform sentiment analysis, we need to ensure the libraries, the dependencies for running sentiment analysis using transformer models are actually installed. So right here, what we need to do is click this play button right here, and well, we have warning. We're gonna do run anyway. And now this notebook we're actually collecting to the server, and now you can actually utilize the cloud service to run everything remotely. So as you can see here, many dependencies have already pre-installed and requirement already satisfied, but we do have one or two, I believe, is okay, data sets. So this is a library we'll be using to pull data from Hugging Face, and that one was not installed by default. So it takes about 20-30 seconds. Let me check time. Oh, about 1 minute already. But yeah, you get a gist. Okay, 49 seconds to actually get all the dependencies installed and checked. So next, we'll be loading all the dependencies, the functions we'll be using for running sentiment analysis. So as you can tell here, it's loading transformers, importing the pipeline right here, and we're gonna loading the Vader lexicon-based sentiment analysis function as well. So it takes about 19 seconds to load everything. So one good thing about this notebook is actually I provided very detailed explanation regarding what each step actually means, what it stands for. So it would be a lot easier for you to make sense of what's going on. Even though it's not currently the focus of our demonstration, but it is highly encouraged that you try to explore and understand the backbone of what we are doing. And feel free to utilize some of the generative AI, ChatGPT, Claude, or even Gemini, anything available on the market to interact. And if you run into any questions, issues, of course, feel free to reach out to me. But before you doing so, there's a more intuitive way to make sense of everything that's actually interacting with generative AI. And that's what we call the transformative power of AI. Well, the highlight of our demo is actually utilizing Hugging Face Transformers library and utilizing the pipeline function. It's supposed to I'm not sure if it's kind of misconception when it comes to sentiment analysis or any kind of machine learning models, that you will probably need a very rich background in computer science. You have to code everything from scratch, and it's very complicated. Well, that is actually a misconception. With all the machine learning libraries available, in particular what we're sharing right now, the Transformers library, you can actually utilize a lot of the pre-trained models to conduct natural language processing tasks, and utilizing those models to reach, well, for your any kind of projects you're doing, and you can get really state-of-art performances. So this is what we're doing right now. We're gonna do 3 pipelines, as you can tell here. And like I said, all you need to do is just click that play button. It will run everything automatically. So as you can see here, we are doing 3 pipelines. First one, we're utilizing the Tweet Roberta. It's a fine-tuned Roberta model. You can actually Google search or use AI to understand, make sense what the model actually means. And second one, we also use a model, sentiment analysis, fine-tuned for sentiment analysis, and this is for multi-language. And lastly, we're going to run a pipeline where we'll be utilizing the traditional, the classic lexicon-based sentiment analysis approach. So right here, as you can tell, we're using the cloud service. So basically, well, think about you're running everything locally, but here we are running everything locally but remotely using Google server. So we're still downloading all the models to the cloud, and we're running everything on the cloud. And right here, we have downloaded 2 models. One is the Roberta model fine-tuned based on Twitter data, and another one is similarly a sentiment analysis model, but it is actually particularly trained for multi-language sentiment analysis. So right here, I want to show you real quick. You can actually find all the models that were actually mostly suitable for your own use cases on Hugging Face. All you need to do is click Models. And right here, I have text classification, and we're now sorting based on trending status. As you can see here, I have this base case fine-tuned model, have this Roberta model, that's what we used for our pipeline. Right here, I have the model car and how many times it has been downloaded and how you can actually utilize it. And right here, if you want to use this model, just click right here, you click Transformers, this is the code, you can just copy and paste. Very straightforward, right? All right, so now we have all the models loaded and set up. We can now run a pilot test using this short text right here, Dr. Q is the best, and to see what kind of output or predictions those models actually make. So know that we have 3 different models. The first 2 are pre-trained models based on BERT. And the first one is trained based on tweet data, and the second one is specifically trained for multi-language analysis, sentiment analysis, excuse me. And the last is Vader, is the dictionary or lexicon-based machine learning model that produce a compound score for the text of interest. So what we're going to do here is just click Run, and now we have the first 2 BERT models producing the labels both positive and scores the actually confidence level, confidence score, how confident these 2 models are in making the prediction. And Vader, as we discussed previously, is a lexicon-based. It's basically calculate all the words in the text and produce a compound score indicating the document, indicating the text, whether or not it's positive or negative. So the compound score will actually range from -1 to 1, if I'm not mistaken. As you can tell here, 0.66 is positive. Now you may wonder, okay, there's no significant difference between lexicon-based and the BERT models, or say the deep learning models. Why, why do we actually promote using of deep learning model, the pre-trained models? Well, the thing is, when it comes to text sentiment analysis, BERT model is actually a lot more flexible and powerful. When I say powerful, we can actually do multi-language sentiment analysis. As we can tell here, we have the modern BERT, and they actually understand context. And Vader, the traditional lexicon um, model, does not do so. So just give you kind of a sense of why deep learning models are generally superior to the traditional machine learning approach. As you can tell here, we use English as a demonstration. We have Dr. Q is the best. If we add, say it is not a correctly spelled text, what will actually happen is that Vader does not recognize um, misspelled words. And as you can tell, it return a neutral score and a 0. So when you use Vader, a very important step to take is actually pre-process the text so that Vader can understand everything in the correct grammatical manner. Whereas you have BERT models, they can understand, well, it's misspelled, and we know what it actually means. And similarly, we test out different languages. Right here, we're gonna do Chinese first. Okay, Dr. Q 是最棒的, that's in Chinese. So as you can tell, well, the Roberta model does not pick up. It says neutral, and Vader also neutral. Whereas I have the modern bird, which is a model fine-tuned for multi-language understanding. Here is positive. And now let's try, what else? Let's try Japanese. Dr. Q, I don't know how to speak Japanese, apologize. But yeah, we can test it. Here we go. Now, as you can see, very similar to what we got previously. Roberta, the English-only model, does not understand what it means. Vader, neutral, compound score 0, and modern bird can also understand Japanese as well. So you get the gist. It's really depending on what kind of task you are doing, and you can actually select different models for your workflow. And it's really important not just blindly select models based on their performance scores, but very importantly understand the context and what can they actually do in different settings. That said, feel free to experiment with other languages. And of course, you can always change the model you like to use. For instance, we have, like I said, and what I showed you previously, auto models right here on Hugging Face are available. And you can do text classification, and we just find this multi-language sentiment analysis right here. What you do is copy this model name, and what you can do, where is it? And just replace it, okay? And then you can just utilize this model. So what this model can do, the model name, base model, and the languages it actually understands. And of course, you will try to make sense of the performance right here. Probably they don't provide evaluation metric. But we will be talking about how to evaluate the performance of those models momentarily. But the key takeaway is always experiment, identify your needs, and make sure you match what the models can do with what you want from the task. Now we have a basic understanding. So now we have a basic understanding of how to utilize Hugging Face Transformers model to run pre-trained large language models or the pre-trained models for sentiment analysis, well, primarily on a short single text. But can we actually create a pipeline that run those models over several, multiple hundreds, thousands of documents? So this is what I'll be showing you right now. Is actually utilizing the data set I created from TripAdvisor. It is a data set of online reviews of Power 5 football stadiums. So right here, we utilize this pool data set function using Hugging Face. And right here, we're going to load this data set. As you can tell here, we have one split, which is test. And we have two columns, text and label. And we have 500 rows. Right here, what we're going to do next is to extract the text column as a list. And we're going to show you the first 10 documents from the data set. As you can see here, these are segments of reviews obtained from TripAdvisor on football stadiums, college football stadiums, excuse me. And now what we're going to do is actually create a pipeline that utilize the models we explored previously, BERT, modern BERT, and Vader, and run those models over the 10 review segments we just saw moments ago. And right here, what we're going to do is actually click the play button, and it will run other models on the server and take 3 seconds to get the results. And then we're going to display them. Right here, okay, you have all the predictions for the BERT models. You have the confidence score for the Vader model. You have compound score, but this is not a really straightforward way to make sense of all the model performances. So we're going to convert the results into a more intuitive manner. As you can tell here, we have text and all the predictions generated by different models. So right here we have, they pack them in their type, doesn't really indicate anything. And they all show neutral. And next, we have the biggest and baddest football stadium on the land. Roberta model and modern BERT model both show negative, and the Veda model indicates neutral. So I guess neutral is because you have baddest. Not quite sure what is going on, but as you can tell, the models are not perfect when it comes to contextual tests. So that's something we definitely want to explore more in terms of their performances. Well, like I said previously, those models perform distinctively, and because we have a very contextual data set, so we really need to do is to perform evaluation. So in sport management literature, we do not see a lot of evaluation being conducted, especially when it comes to sentiment analysis. And in my opinion, that's not a good practice, and definitely there's room for improvement. So what we do here is actually evaluating those models as they all produce very different predictions, and we're going to use their predictions against or evaluate their performances based on human annotation, human evaluations, to see how they perform. So we have a few key metrics to cover right here. Accuracy is basically the overall correctness, of predictions. Precision, as you can tell here, is the reliability of positive predictions. Recall is the model's ability to capture all relevant cases. And finally, we have F1 score. It is the holistic metric that combines precision and recall into one balanced measure. So, so please feel free to dig into more details about how those evaluation metrics actually work. But what we do here is actually utilize the same data set we used previously. If you recall, we have text and label. The label actually um, provides the annotated or the predictions made by human beings of those text or review segments you see just now. So again, we're going to load the data set, and then we're going to show the first 10 review segments. As you can tell here, we have the tests or review segments, and we have their labels, which were provided by human beings. So one basically indicates neutral, two positive, and zero negative. So next, what we're gonna do is actually run the pipeline again and generate scores for all the 500 rows or the 500 review segments. So we're gonna hit the click right here. So we're running everything on CPU, which might take a little bit longer. You can always, click right here. Right here. You can change the runtime to T4 GPU. If you're a free user, you can still use GPU, which will most likely accelerate the computation process. But right now, we just stick to CPU for demonstration purpose. So run about 2 minutes, which in my opinion is pretty acceptable with over 500 review segments. And we generated predictions based on the three models we explored previously. So what you're gonna do next is actually click this play button and run this cell, and it will give us the performance metric against that 500 review segments. So as you can tell here, Roberta certainly outperformed the other two. And as note here, Veda is actually not too bad, but still, compared to Roberta, the deep learning model is still falling behind. Keep in mind, we can still fine-tune Roberta model to improve its performance using additional data. By additional data, I mean the text and the label provided by individual human readers. So as you can tell here, the modern BERT is not performing well, even though it's a deep learning model. And you have to consider the context for sure is the sport management context. And also you have to consider modern BERT is actually fine-tuned for multiple language sentiment analysis. So with that said, I believe you get a gist regarding how to properly utilize different models for different tasks. Like I said multiple times in our demo today, is you have to understand your needs and what the models can actually do that will actually address your needs.